Hey guys, Mr. Gilsdorf here, and this is Unit 7, Solutions and Acid-Base Chemistry, Section 6, Types of Acids and Bases, and we're going to talk about naming of acids and bases, and this video is for Honors Chemistry. Okay, the first delineation we look at with types of acids and bases, we know now that acids are proton donors, bases are essentially proton acceptors or hydrogen acceptors, and quite often they also produce hydroxide ions, whether they produce it directly from themselves through dissociation or whether they force water to dissociate into hydroxide, just depends on the strength of the base itself, okay? So acids, we also can refer to them based on how many hydrogen ions they're going to release. So what we call a monoprotic, and the protic referring to proton, and the proton is a hydrogen ion, right? Hydrogen ion is, hydrogen is a proton and electron. Once it loses an electron, it has a positive charge, so it's a proton. So monoprotic, mono is the prefix for one, so that means that these are acids that can only release one hydrogen ion. Diprotics release more than one, release two. Triprotic release three, and then there's not really going to be anything past that. So what we refer to, or the reason we use this is because sometimes we refer to the acids as being different during titrations. And we'll get into what we call a titration next week, but during titrations, the monoprotic acids versus diprotic or triprotic are going to be different. They act different, so we keep that in consideration. Bases are going to be the same way, mono, di, and tri, but we refer to it as monobasic, dibasic, tribasic, just depending on how many hydroxides ultimately they are going to release. Okay, so in naming acids, acids fall into two major categories when they're naming. We have our simple binary acids, binary meaning two, so referring to elements, or excuse me, acids that only have two ions in them, or two elements in them. So a couple examples, HCl, HF, H2S, HBr, HI, anything that's just going to be simple binary, okay? When we name those, we start with the prefix hydro, then we start the root of the second ion, and then end it with ic acid. So for example, HCl, hydrochloric acid. HBr, Br is bromine, so it becomes hydrobromic acid. H3N, N is nitrogen, so it becomes hydronitric acid. Complex oxyacids are going to be acids that involve oxygen and usually are going to be hydrogen with a polyatomic ion. And so the way we name those, it has two basic categories. So we have the ions that end with ATE, and we have the ions that end with ITE. So if it's a polyatomic that ends with ate, such as carbonate, nitrate, sulfate, etc., then we change the N to ic acid. So carbonate becomes carbonic acid, nitrate becomes nitric acid, etc. If the polyatomic ions ends with ite, then we change the ending to us acid. So the best example is the difference between nitric and nitrous. So nitrate is NO3, nitrite is NO2, and that becomes nitrous acid. And then sulfate is sulfuric acid, and sulfite is sulfurous acid. Naming bases kind of follows along, and it's not perfect, and this is not a perfect delineation here, okay? So I'm not saying that this is always how it is, but most of our strong bases are going to be bases that contain hydroxide, and as such, they are going to be an alkali metal with usually what we refer to as a heavy alkaline earth metal with hydroxide. Therefore, they're ionic compounds. Metal plus hydroxide, which is an ion, so we just name them as ionic compounds. So we name the first element, and then we name the second ion. So ion, ion, sodium hydroxide, ion, ion, barium hydroxide. Weak bases are often going to be covalent compounds that accept hydrogens. Therefore, we either call them by their molecular compound name, so like NH3, nitrogen trihydride, but we also sometimes call them by their common names, such as ammonia. And I put here a notable exception. So this is a notable exception because this is a weak base, and you'll notice it's all nonmetals, so it does kind of feel like a covalent compound, but it is named as ammonium hydroxide. All right, I want you guys to practice the naming of acids and bases, and I'll see you next class.